Today we shall be learning how to solve problems involving bearing and distance under trigonometry. And to do that, we have a question here on the board which states a student walks 5 kilometers from A to B on a bearing of 0.35 degrees. She then walks 6 kilometers from B to C on a bearing of 125 degrees. Calculate A, the distance AC, B, the bearing of C from A. Now, to answer a question involving bearings, you must first be able to draw the correct diagrams, particularly for students who find it confusing solving problems involving bearings. So this is how to go about it. First, the diagram. Now, in drawing the diagrams, when it comes to bearing, we use the cardinal points to begin with, okay? And you label it this way. The north pole facing this direction, the south, the east, and the west. And then you begin to measure your diagrams from the geographical north. Usually, when it comes to trigonometry, if you have the same diagram in this sense, okay, and you want to measure the angle, okay, in the proper sense of measuring angles in trigonometry, you start from the 0 degrees in the anti-clockwise direction, but not in the case of bearing. When you are solving problems involving bearing, you start measuring your angles from the geographical north in this direction. So we have it as 0.35 degrees, telling us that this angle is measured from the geographical north, and that's why you have it as 0.35 degrees here, not up to 90 degrees, and so it stops somewhere here, and then you go. So this angle here is 0.35 degrees. Okay, you now make another cardinal points here in that way. Okay, so this is your point A, and this is your point B, all right, which is given to us as 5 kilometers. You label this as 5 kilometers, all right. Then she walks again 6 kilometers from point B to another point C on a bearing of 125 degrees. Again, from the geographical north, which is this point, you draw you measure your angle from the geographical north in this direction, in the clockwise direction, okay, 125 degrees. Now, I'm able to measure it as 125 degrees because I know that from here, since here is a point 0 to 90 degrees, from 90 degrees, you have another 90 degrees, which makes a 180 degrees. Okay, so between 90 degrees and 180 degrees, you can get your 125 degrees. So from that point, you rule your line this way. So from this point to this point gives us angle 125 degrees. And then you can connect, this is your point C, you can connect your point A to point C. Okay, having gotten this, I know the distance given to us that she was from point B to point C, a distance of 6 kilometers. So the question now says you should find the distance AC. That's the first question, finding distance AC. In order to achieve this, you must be able to get certain angles, okay, critical to answering this question. First, let us sort this out from this point. The line joining points A and point B is actually called a transversal because we have two parallel lines, the geographical north of point A and geographical north of point B. The north-south line are both parallel lines, which makes the angle in this part of the triangle the interior angle of the triangle. So this is alternate angle of the triangle, 0.35 degrees as this. So angle 0.35 degrees is the same as angle 0.35 degrees in point B. The one in point A and the one in point B are the same because they are alternate angles. Okay, you are left with another small angle here to figure out what it is. And how do you figure that angle? You know that the angle from this point here to this point is 125 degrees. What is left of this to make it 180 degrees is the difference between angle 180 degrees, this angle on a straight line, and the angle that has been given to us, okay, the bearing 125 degrees. So if you subtract 125 from 180, you get 5 and 5, 0.55 degrees, 0.55 degrees, which means the angle from this point here to this point, if you add it up, it makes angle 90 degrees, 0.90 degrees. So the angle within this point here, point B, is angle 0.90. So that makes it easy for us to solve. The next step is to apply the cosine rule. So applying the cosine rule, okay, which states that generally, let's say this is our point, for instance, say point, let me call it say point B, because we have this as B. Let's say this is B. B squared equals to A squared, the sides, this side is the side, this small a representing the side, BC, A squared plus B plus C squared, okay, which is the side facing the angle C, minus 2AC, the two sides multiplying themselves, cos B, the angle at B. So applying this into with the information that we have here, we have B squared, which is the same thing as your side AC, is equal to A squared, which is 5 kilometers squared. Let's just write it as 5 squared, plus 6 kilometers squared, 6 squared, minus 2 times A, 5, times B, 6, cos B, cos 90 degrees. So when you do this, you get 25 plus 31 minus whatever you have here reduces to 0, because cos 90 degrees is 0. So 2 times 5 times 6 times 0, because cos 90 is 0. So everything here becomes 0. So what you have here becomes B squared equals this is 36. This squared equals 61 kilometers squared. Okay, let's come to this solar side to complete the work. Coming to this solar side, we now have our B squared as 61 kilometers squared. 61 kilometers squared. So your B equals the square root of 61 kilometers squared, which is about, if you punch your calculator, that should give you square root of 61 should give you about 7.81 kilometers, approximately 7.81 kilometers. So distance AC is approximately 7.81. So that's the first answer, question A. Now we go to solving question B. It says find the bearing of C from A. The bearing of C from A is the angle from here that measures from this point to this part of the triangle. So it continues to this part of the triangle. So this is the angle to locate. Getting this angle, you now measure from this point to this point. So let's label this angle as angle x degrees. So when we add angle 35 to angle x degrees, we get the bearing of C from A. But the problem is, how do we get the solution to angle x degree? How do we find x degrees? We apply the sine rule. So applying the sine rule, and how do we apply it? Okay, the simple rule is this. Let's choose, let's say, the same angle we're looking for. So angle x degrees, angle sine x degrees all over the side facing it equals to angle 90 degrees all over the side facing it. And the side facing the angle 90 degrees is 7.81 that I just calculated. So we have sine x degrees all over 6 kilometers is equal to sine 90 degrees all over AC, which is 7.81. Sine 90 degrees is equivalent to 1, equals to 1. So we have this is equal to 1 all over 7.81. So it is equal to get our x degrees by cross multiplication. So sine x degrees equals to 6 all over 7.81, which is equal to, if you punch your calculator, you get 6 divided by the answer gives you about 0.7682, approximately 0.7682 is sine x. So getting your x degrees, you take the arc sine of 0.7682, and when you do that, this is what you get. Okay, so and that gives you about 50.19 degrees. 50.19 degrees. But then the question says bearing of C from A, which means you add up 35 degrees plus what you have as x. So bearing of C from A is 0.35 degrees plus x degrees, which is equal to 0.35 degrees plus 50.19 degrees, and that gives you approximately 0.85.19 degrees. And this is how to solve problems involving bearing and distance. If you find this solution helpful, kindly like and subscribe for more. Thank you for watching. Bye bye.